Lydia. I'm a mathematics teacher, and I would like to explain today about probability. You know that probability is a part of mathematics and it's a science. Now it's recognized as a science, but some years ago it was not recognized as a science. Probability, the best definition of probability is perhaps that it just measure how certain you are that something is going to happen. And so are the chances that we have about something will occur. So probability is about the chances that we have that something will occur, that something will happen. In the study of probability, we use numbers. So we have from 0 only, 0 to 1. And we have to measure the probability between 0 to 1. And we use fractions and we use decimals. Yes, when an event is impossible, if you have any question, please stop me and we ask me. Okay? We have 0, we have an impossible event. It is an impossible event. And we have 1, we have a certain event. The higher number, more likely to the event, is the closer to probability is 1. It's more certain and it is 1. And in the other one of the scale, unlikely events have very small probabilities. The number is close to 0. So here we have likely, and here we have unlikely. Likely probability and unlikely probability. You understand that? Yes. Okay. How we express our measurement in fraction and decimals. For example, if you have 0 and 9, it's very certain event. And if you have 0 and it's very impossible. It's near to be an impossible event. So we measure the probability with the numbers near 0 or near 1. For example, if you have here, what happened? If I am here, is likely or unlikely? We have the same probability that the event occurs because I am in the middle. The event occurs or may happen certain or impossible because I am in the middle. You understand that? The probability of an event we can express as a fraction, and we must define it. With a fraction in which you have the probability of an event the probability an event is. In the bottom of the fraction, we have the total number of outcomes. And in the top of the fraction, we have the number of successful outcomes. Do you understand? Yes, for example, we have a die. You know what is a die? We have a die. I will roll a die. How many possibilities we have that to get, for example, the number 1? How many possibilities? 1. So the number of successful outcomes is 1. And which is the total number of the outcomes? 6. So, if I have to express how many possibilities I have to the outcome, I have 1/6. For example, if I have a coin, how many possibilities I have to get heads or tails?
50%. 50% is
Yes.
1/2.
So, the number of successful outcomes, for example, I want to get heads.
Was 1.
Okay. And we have the number of outcomes,
2.
2. If I have to express in decimals, it's 0.5. This is very simple. For example, the probability of a coin landing on heads is, we have to say that, 1/2. And the probability of a coin not landing on heads, which is, if it lands on heads, we have this. If it lands not in heads, which is the probability? The probability is 1 less minus 1. Yes, you know? So it be the same. I have the same probability, the same chance. It is expressed in a mathematical theory. So, and for example, the probability of the die landing on 6, the first example, landing on 6, is 1/6. And if not, which are the other possibility? If the die is not landing on 6, for example, or only 1, which is the possibility? The possibility is 1 minus, it is 5/6. So it is one possibility, is another possibility, no? And for example, the probability of a roulette ball landing in a specific slot is the number of the possibility, because I choose a number, and I have to know the total number of accounts in a roulette, which is the total numbers of accounts. You know what is a roulette?
Was it 100 or 99? I don't know.
There are 36 numbers and 0, so 37. There are the possibilities. We have those possibilities. And if the probability that the ball that is not coming in the number that I want, it will be 1 minus. So the probability is, I have the probability to have my number is very high, and the probability that I lose my money is less, you know? And in mathematics, we have to represent probabilities in different ways, but it depends on the events. We can have one event, or we can have different events, and the different events we can combine them. So the way that we represent in mathematics the probabilities are different. In the first example, when I have one event, I use a line. One of the ways that I can express is a line. So I have a line in which I have 0 and 1, no more. And I have, for example, 8 parts, 1, 4. And so on. So here I have all my possibilities. We know that it's unlikely and this is likely. That impossible are certain, yes. And for example, when we have, well, we'll do an example for it. I have in a bag, I will do an example. I have in a bag coins. I have a bag with coins. This is a bag and I have coins. And I have, for example, 2 coins of 10. 2 coins of 25, 4 coins of 25, and a coin of 5, a coin of 10. Which are my possibilities, my probabilities of getting, for example, a coin of 10 in the bag? I have to express in mathematics which are my possibilities.
3 over 8.
Yes, what we'll do graphically. How many coins do we have? 8. We have 8 coins. We have 8 coins. So, how many coins we have? About 10. We have 2. What? 3.
3.
We have 3. We have 3 over, which are the total amount? 8. Yes, it's about 25.
4 over 8.
We have 4 over 8. And about 1?
1 over 8.
We have 1 over 8. If I have to represent this in my line, I have 3, 8 here. 3, 8 are the 10. I have 10. And 4, 8. And I have 25. And 1. And I have 1 pound. Yes. So, which are the probabilities that I get the coin of 1 pound?
It's unlikely.
It's unlikely, very, very unlikely. And which are the probability that I get in the bag the coin of 25? It's
50%
yes,
chance.
and it's more likely. So we can represent the probability in a line in this way. We have another kind of events. Well, here we have only 1 event, but we can have 2 or more events, and they are combined. We can have 1 event, and then we can have another event, or we can have 2 events in the same time. So, for example, in a probability of combined event, 2 things that happen at once or after each other, or in the same moment or after each other. So we can combine the events, and we have an event and another event. Or we have 1 event or another event. There are 2 possibilities and completely different. So, for example, we have to know which is the chance, which is my possibility when I roll a die to get a number, and in the same time I have to know which is the probability if I flip a coin to get the head, for example, in the same time. So I have the probability in the die to get a number is 1 over 6. Okay. And the probability that I get a head in a coin is 1 over
2.
So, if I want to know which is the probability in the 2 events, both events at the same time, I have to say, I have to multiply. I have 1 event, 1 probability that I have obtained 1 number, and the probability of another. And what happened here? What happened with this kind of combined probabilities? I have less probability, have less chances. If I had two events at the same time, and I want to get a number here, and I want to get a head here, I have less probabilities. And in the second combined event, for example, I have a probability to get a die, to get a number of a die. And then I want to get, for example, in the same time, with a die or with a coin, I have, for example, to get tails. I have two probabilities, one or another. There are no both, one or another. So I have to plus. So, which is the result for me? It is 6 over, well, I will do it.
3.
Yes. 3. No, that's wrong. It's actually wrong.
No, it's 3 over 6.
Yes, 3 over 6. The result will be so, if I have an event or another event, I have more or less probabilities. I have more probabilities.
Okay, thank you very much, yes, and we've run out of time now and the students will have their break as well, so thank you very much. Can I ask students to fill in your feedback forms and I'll just walk with Lydia to take her to the next part of the process. Thank you. Yes, I know that you will be very It will be 20 minutes. Yes, yes. Ah. So if I take you to the next meeting, yeah. Thank you. Goodbye. Thank you guys. Thank you so much for that.
Nobody has to make F6.
Yes.
It says 3 times 2. It says 3 times here and times here.
Yeah, so then we have
What's the probability that you'll let you have these?
Anyone on this page?
I might come back. Go on, picking one out then. Decide who you give it to then.
Choose one. For the accent.
Merry Christmas. Merry Christmas.
Thank you.
Thank you for that.
But still work.
Guys, you have actually run over and I do apologise.